Hello,
My name is Pavel.
my name is Pavel.
Welcome to a new Cube video.
Welcome to a new Cube video.
In this video I show you how to synchronize multiple CubeGUI instances.
In this video I show you how to synchronize multiple CubeGUI instances.
Let's do it.
Let's do it.
So we are back to our terminal, and today we would like to learn a little bit about another feature, maybe unusual and maybe a little bit advanced, but nevertheless a very useful feature, how one can synchronize two or multiple instances of CubeGUI and for what it might be useful. So let's take a look, and we open Cube. And for example, typical scenario, one made multiple measurements with different settings, for example, and one would like to compare values which one obtained. Metric, time, runtime, visits, and so on. So in this case, we have, for example, here a result of benchmark with puppy counter or without puppy counter. So and I would like to compare the metric value. So let's open first the cube file with puppy counters. So it opens again the cube file. I have hidden the system tree here. Usually one can keep it open and look at these values as well. It's very useful, but for this demo I just hid it. So it opens our cube, and that is our metric dimension. This is our collapsed call tree. And let's take another cube file. For that we open cube, and we open the cube without traces, without puppy. And so we would like to compare the values. So typical way would be naive. I would put the window next to each other and actually repeat all selections in one and then in another. And then here, and then here, and then here, and then here, and hope, okay, so here I have something, and then I want to open, it's here, and then I would like to see this value, so I have to find it again, and then I have to open, and okay, that was iteration. So again open, that was compute, RHT in ADI, so I have to open ADI, it's here. So as you see, that's a very tedious process, and especially if the cube, the call tree is very large and has a lot of very similarly named call passes, maybe that is instrumented class or something similar. So one would definitely make mistake, and one has to pay attention. That's very tiring. And like for example, here is one can have one metric here and another metric is here, and one would like for example this one, so similarly named MPI add something, here is MPI something, here I see that here is 4000 something and here is 0.20, like that cannot be true, and only because I selected here different metrics and I didn't notice. So it's very, very tiring and highly inefficient. So for that we actually offer this synchronization feature. Where do we find it? One goes to display menu, and here down show synchronization toolbar. So one selects it here as well, and one has here drop down menu, and here is a list of trees and two buttons. One button is send state and another button receive state. So basically what it does, if I send my state, so this GUI would send its selection state to another GUIs, and those GUIs which do receive it, they will receive it, as it just says. And the state, with state we mean selection in a tree and the expansion state. Yeah, so like in this case, expanded this call path, BT, this level, initialize, and this level up to that level. So that is just expansion state and the selection. So we would like to synchronize all our trees and our left GUI will be leader, so I will work here, and the right GUI will be simply follower basically, so I will receive state, and you have seen immediately it reproduced the state because the left GUI already sent its state. So in here I can, when I select something, the selection in the left GUI gets repeated. And in this way I actually don't need to bother anymore in selections in the second GUI. I know that it will be identical. Identical because we have two, let's say, identical measurements. The GUI tries to reproduce selection state as far as it can. For example, if it would be missing here compute RHS, it would expand everything except of this call path. And so this one has to keep in mind. If the measurements are identical, of course the trees expansion would be identical, but if they don't, if they are not identical, then it will be different, and of course then one has to understand what's going on. So in this case, for example, we have the measurement with puppy, here with no puppy. We would like to see maybe there is some difference, and let's take a look. So okay, in computation here we see here is rather minimal difference. In MPI we have remarkable difference in runtime, although MPI itself it's only 6 seconds in comparison to 200, so it's maybe even to neglect. But let's take a look. So the differences here in MPI setup, this is nearly identical, this is nearly identical, verify is nearly identical. So let's take a look what the setup is different. That is init thread is in the case of puppy takes longer than in case of no puppy. Good, that is already something. And if we go to, for example, OpenMP, we see that measurement here takes longer, and synchronization takes longer, and that is somewhere in barriers. So as you have seen, I didn't need to click on a right GUI anything, and I can work with one GUI and just visually compare one value with another because selection is completely identical, so it's very easy to follow. That is scenario when one has basically two slightly different measurements maybe on the same machine. Another scenario is possible if one made the same measurement but on different machine. That would work too. That is also advanced part of this feature. So for that, for example, I can log in our system, and here I already prepared a cube file. That is actually very same cube file in this case because I copied it, but let's see, let's understand it as it would be identical measurement on different machines. So we see that here it is open, and our synchronization bar is under display, and again our right GUI will be the follower, so it will receive the state. And let's see, if I click on computation, it expands here identical, also with all the submetrics. Although I didn't click them, nevertheless it expanded it and repeated all this expansion state also in a call tree. So for example, I see that of course the values are the same. Here is the display is different because of settings in this GUI. You can in precision settings how to change it. I explained in one of the earliest videos. Take a look. And here we can work through our measurements. So as we have seen, we are repeating or synchronizing all four trees, for example, metric tree, flat tree here, and we are also reproducing it. So for example, we can open here flat tree and select here some regions. Well, we synchronize the selection state, but we unfortunately not yet do not synchronize the fact that we selected the flat tree, so one has to select it here explicitly. And then if one works with this flat tree, then selection is repeated in a right flat tree. So that is how this functionality, how this feature works. Hopefully I could demonstrate that it simplifies very much the comparison between two measurements, to different measurements, or to the same measurements on different machines. One can maybe use this feature also for demonstration purposes, so that there is a one GUI where one clicks, and all other GUIs which probably are displayed on another displays or on other machines, they are reproducing the state, and I would say students, they can follow then such live demo. That would be maybe unusual usage of this feature, but nevertheless it's possible. So I hope you liked this video. Please comment, give us subscribe and give us a like. Thank you very much, and see you next time.